Algebra 1, Lesson 98. We are solving quadratic equations by factoring. So we're using a zero product property in order to solve this. And what we're looking for is these roots of an equation. We've called them other names. They're also called x-intercepts or zeros, and they're really just the solution to the equation. So quadratic equations, remember, can have 0, 1, or 2 roots. And we use this property that says if the product of two quantities equals 0, at least one of the quantities equals 0. So if we have two things multiplied together, one of them has to be 0 or the other has to be 0. So what's the difference between a quadratic equation and a quadratic function? A simple answer to this is how many variables there are. In a quadratic equation, we just have one variable. In a quadratic function, we have two that we can graph and put on a number on a coordinate plane and find the actual x-intercepts. So let's practice just with a quadratic equation first to understand this. So we have a quadratic in factored form, x minus 4 times x plus 5. And if we were to remember what this would look like in expanded form, remember we would multiply it all out. And you can try that yourself, but you would end up with x squared plus x minus 20 equals 0. And so if we were given that original quadratic, x squared plus x minus 20, we could factor it into this form. And then what we're saying is, since we have two quantities that are multiplied, one of them has to be 0. So either x minus 4 has to be 0 or x plus 5 has to be 0. So we can go ahead and solve each of these possibilities. So x minus 4 equals 0. We would add 4 to each side and get x equals 4. And the other one, we would subtract 5 and get x equals negative 5. So we could do this with this one as well. What we're saying is either of these two quantities can be 0. So I like to split it up like this and look at each side so that we can say x can be 3 or x can be 8. And those are my solutions. And what it's saying is that if we were to have this as a function, so y equaling 0, we would end up with this quadratic, and it's not going to be perfect here, but it's going to look something like this. And so that we have two different distinct possibilities. Okay. For this one, ends up that it's 3 and 8. In my first case, it would be negative 5 and 4, something like that. Just depends on your quadratic, of course. All right, so what if it's in this form? It's not factored yet. Well, just like the other two, we need to do a couple things. Number one, we need to get it to equal 0, which means one side of this equation has to be 0. So we subtract 8 in this case. And we get x squared plus 2x minus 8 is equal to 0. And then we can go ahead and factor this to say what multiplies to give me negative 8 adds to give me 2. And of course, that's going to be x plus 4 and x minus 2. That equals 0, which means either x plus 4 equals 0 or x minus 2 equals 0. So we can say our solutions are x equals 4 or x equals 2. And if this were a function with it equal to y, we're saying those x-intercepts, so y equals 0, would be at negative 4 comma 0 and 2 comma 0. All right, similar process here. I'm going to do this one quick. Get it equal to 0, x squared plus 5x plus 6 equals 0. So we factor it and get x plus, x plus 3 and x plus 2 multiplies to 6, adds to 5, which means that each of these quantities could be 0. So x could be negative 3 or x could be negative 2. So those are my solutions. So we are factoring these and making sure that we know the solution. Now, all of these can be done, and you can work through some of these. I'll just do one of these. But same process here. We just take a little bit more time in order to factor. We get it equal to 0 and get 7x minus 19x minus 6 is equal to 0. And so since this is a little bit more complex, we can use one of our methods. We could do the good guess and check, or we could do our AC and B method. So I'm going to do the AC and B method. So we look at A and C, so 7 and -6. So we get -42. We multiply those. And our B value is -19, which means I need something that multiplies to -42 and adds to 19. Well, if we think about it, we could say, 1 and 42, that's not going to work. 2 and 21, well, 2 and 21, maybe one of them is negative. What if we have a -21 and a +2? That would equal -42 when I multiplied, and it does add to -19, which means we split this middle term into -21x and +2x. And we have our other parts here, 7x squared, and we have -6, which means we now can factor by grouping by saying the first group here, I can factor out a 7x, so we have an x minus 3, and the second part I can factor out a 2, so we end up with an x minus 3, which is good because that x minus 3 is in common, so we can say our factorization is x minus 3 times 7x plus 2. And that all equals 0, which means each of these parts could equal 0. So we get x is equal to 3. And on this other side, we can say I'm going to subtract 2 to get x alone. We get 7x is equal to -2. Divide by 7, and we get x is equal to -2/7. So we say our solutions are 3 and -2/7. You can try that same process on that second one on the board, or you can do a good guess and check with that one. All right, and sometimes we do need to go through our full checklist here to say, is there a greatest common factor first? Well, we first need to get everything on the same side. So let's try it with the top one, and I'm going to get everything onto, let's say, the right side of the equation. So I'm going to subtract 20 and add 2x squared on each side. Subtract 20 and add 2x squared. We end up with 0 is equal to, let me erase a little bit of this so it's a bit easier to see. All right, so remember we subtracted 20 and added 2x squared. Excuse me. All right, so we end up with 0 is equal to, this board just wants to draw these lines today. So we get 2x squared minus 20x and then plus 50. Now, yes, we could go through our full method here of A, C, and B, or a good guess and check, but it's actually easier if we factor out that greatest common factor. So we see 0 is equal to 2 times x squared minus 10x plus 25. And then we realize this is actually one of our special binomial, or special products here, because it is a perfect square trinomial. So we say 2 times x minus 5 and another x minus 5, which means we're still equal to 0, which means either this quantity has to be 0 or this quantity has to be 0. So my solution is here 5 and here 5, which means I just have one solution. X could be 5. Okay, and you can try that with the second one as well. Just factor out that greatest common factor first. It'll make things a whole lot easier. Let's look at a real-life example and then finish up this video. So the area of a rectangular garden is 51 square yards. The length is 14 more than the width. What are the length and the width of the garden? So if I have a rectangle here, what we're saying is this garden has a width of x and a length that is 14 more than the width. So we say the width plus 14. And we know that the area here is 51 square yards. Okay, so we can set up an equation here in order to figure out what is x. So we say, if I have this area of 51, that must have come from my width times my length, which means I can go ahead and expand to get 51 is equal to x squared plus 14x, and then subtract 51 to get it on the other side. To get 0 is equal to x squared plus 14x minus 51. And then, just like we did on the other pages, we're going to go ahead and factor this. Well, 51 is the same as 3 times 17. So let's see, I could do x plus 17 and an x minus 3. That would give me a negative 51 and add up to positive 14. Which means when I look at each of these possibilities, we say x could be negative 17 or x could be 3. Well, my first option here, negative 17, if I have a width of negative 17, that doesn't make a lot of sense because we can't have negative dimensions of something. But x equaling 3 does make sense. We could have a width of 3, and that means that our length is 17, which does give me an area of 51 yards. Okay, here's another example that's similar to it that you can try for yourself using your quadratic functions and factoring. And then here's some other possibilities that you could have. Remember, if it's something where it's a special product or something where you can factor out a greatest common factor, do that. It's a lot easier to work with those different patterns that you have rather than going through a whole big process. So for example, this 9x squared minus 4, I would say that's a difference of squares, so it's a 3x minus 2 and a 3x plus 2 equaling 0. And I could find my different solutions here. And you can try these on your own and see how you do. All right, well, I hope this video is helpful for your homework and for studying.